Hello, my name is Hanif Rahbari. I'm an assistant professor at the Department of Cybersecurity, Golisano College of Computing and Information Sciences. My research area is at the intersection of wireless systems, cybersecurity, and experimentation. Specifically, in my research, I use applied cryptography, formal protocol verification, implementations and prototyping, machine learning and deep learning in order to study the vulnerabilities in wireless communications, as well as proposing solutions that can protect wireless communications from attacks. Specifically, one of my main research areas is on security of connected vehicles. Over the past years, we have seen a continuous increase in the death on the roads because of the vehicle accidents. And the main reason behind the accidents on the roads is because of the human mistakes. The technology is coming to help vehicles and the drivers of the vehicles. And one of these technologies is the technology called connected vehicles, in which the vehicles can talk to each other over a wireless medium, basically over the air, and help each other to prevent accidents. And that also helps to move towards having autonomous drivers and autonomous driving in near future. But as we bring in technology, we also bring risks, specifically cybersecurity risk. Now the attackers with the technology in place could impact the security of the vehicles and bring about attacks that did not exist when that technology did not exist. So that's one of my main research areas. We study how the attackers can disrupt these systems, how the attackers can abuse these systems to mislead other vehicles, how future quantum computers can in fact break the security of these systems. Another research area I'm focusing on is about the coexistence in shared spectrum. So it turns out, as we all know, that the use of mobile devices, the use of wireless technology is growing at an exponential rate. So wireless carriers, internet providers, they all want to support more users, and the users have more demands. The users have more devices, the users watch more media or videos, and do more with their wireless devices. And this increased demand or bandwidth demand, at the same time with the increased interest in having low latency communications for a wide of applications, would require more bandwidth. And as you might know, that bandwidth is a limited resource. The standardization agencies and the governments are allowing having different technologies or heterogeneous technologies share the same frequency band. So when now these different technologies share the frequency band, that brings up a set of new cybersecurity questions. For example, how these different technologies that are going to use the same frequency band are going to trust each other, how these different technologies are going to share the band fairly, whether or not an attacker can abuse any coexistence mechanism to make the system biased towards one technology over the other, meaning that the sharing is not going to be fair, and so on and so forth. And the third area I'm focusing on is the security of wireless communications at the physical layer. That means when the signals leave the radios at a transmitter, that signal contains and embeds some information about the type of signal or type of information it's carrying. And like 20 years ago, that was a good thing to use technology or some advanced communication techniques for enabling wireless communications. But now the attackers are able to use that knowledge about wireless communication to infer some information about the information being exchanged, and in order to launch various types of attacks. So one of those features that wireless signals carry in wireless communication is called digital modulation, or basically demodulated symbols. that carry information. My third research area is how we can protect the modulation scheme and modulation symbols from different types of attacks, ranging from traffic analysis to privacy attacks to jamming attacks, and so on and so forth.